saying who? You.
Me?
We get we spent like 50 minutes
Not
on
just
one
my
talk.
speaking.
I haven't taken one Spanish test, and I just aced all the assignments. It's a 180 Spanish test. It's so great.
I made none of the Spanish test.
I'm like, dang.
You know we're in Unit 4, right?
Yeah, I was like
He's not.
flipping through the books,
Oh.
and I stopped at 50.
43?
I realized there was the notes.
4-4, right?
Four, four. I'm
50.
behind. 57, I think.
We usually see shit.
I'm dead with them.
All right, I'm rewriting it.
Huh? It is?
Okay, I'm already rewriting it.
Uh,
Find local extrema, determine intervals concave up and which is concave down. Find any points of inflection. So, this is a product rule. So, especially for those people that don't know how to take derivatives, really need to pay attention. So, implying, you know, whatever affinity with cocaine you have, pay attention. So, this is F, this is G. So, F prime is 2x, G prime is 1/2 1 minus x squared to the negative 1/2 times, what's that going to be? Negative 2x. So, since product rule, we good there, right?
hold on.
Uh-oh, did we have an issue? Was it the negative?
Yeah. Okay.
You don't do any of your homework problems on the board? Yeah, I hate to interrupt your drawing. What the hell? Yeah, no. It's almost like it's a math class assignment. Anyway, so f prime g, so it's going to be, let's see, 2x times 1 minus x squared to the 1/2 plus g prime, which is all of that times f. So x squared times, what's that going to be? That's going to cancel that, so it's a negative x 2 over 1 minus x squared to the positive 1/2 out here. So I wrote it in fractions to try to clear it up. So there's my product rule, and that's equal to my f prime, f of x prime, like that. So this is going to be my first derivative, so I'm going to use this to find my points of inflection, or my, nope, not points of inflection, I'm finding my, yes, there, critical points, there we go, critical points, because it's not always going to be where it's going to be equal to 0, it's also undefined. So right here, set it equal to 0, I get 2x quantity 1 minus x squared 1/2 plus, what's that going to be? A negative, oh wow, that cubed over 1 minus x squared Alright. I wrote it like this for a reason. Why did I write it like this? Especially at this point right here. I need to set everything equal to 0. But before I can set it equal to 0, I have to have... Very good, yeah, common denominator. I have to have common denominator, thank you. So I gotta have common denominator. So, multiply with this side over here, so I get 0 equals, when I multiply this here, I'm gonna get a whole, because I add the exponents, so that's 2x quantity 1 minus x squared, and that's gonna be 2 over 2, and that's gonna be plus, or a minus over here, and x cubed all over 1 minus x squared 1/2. My board's glitching right at the back arrow. So, now, looking at this, I want to have critical points, right? So what would be one of my critical points right here? 1. Anywhere else? That square is going to do something.
Yes. It's square.
It's going to square. What happens when you square stuff?
Multiplies.
Okay, and when you multiply two of the same numbers together, I always get a what type of number?
You're just talking about just the denominator right now? Or
Yeah, just this piece right here with the x squared. If you square any number, what must happen? It has to be.
Oh wow, -1.
Okay, so -1. It has to become positive, right? If you square any real number, it has to become positive, right? So that would also work. So I have a positive one and a negative one. Okay, so my critical numbers, right there. Okay, what else with my domain here? Because this is a 1/2 power, what can I not have inside that 1/2 power? What's that 1/2 power mean again? Very good, square root. So in a square root, what can I have? Can't have negatives, right? So that means that x has to be, okay, but what's going to happen here? Because it's 1 minus x squared. It's got to be less than 1, right? Because whenever I have anything more than 1, I'm going to get a negative inside there, right? Because it's 1 minus the x squared. So my domain is going to be restricted in between 1 and -1. Because of that right there. So I'm only going to be dealing with a certain part in between there. Okay, that's good. So that's plus or minus 1 right here. So now I'm going to multiply both sides by the common denominator. And what's going to happen to that denominator there? Clears out, right? So I get 0 equals, I can distribute this, 2x minus 2x cubed minus x cubed. Are we okay still? Now, I'm going to go to another page because I hate, bending over and being on the bottom of the page. So it is 0 equals 2x minus 2x cubed minus x cubed. So 0 equals 2x minus 3x cubed. Can I do any factoring? Yeah. So I should have taken an x. I get 2x minus 3x squared equals 0. Okay, so 0 product this, so I could say x equals 0. That's one of my critical numbers. And I get that from right here. Yeah? Did I lose you? Because 0 product, if this is 0, the whole thing is 0, right? So that makes this true. So now I'm going to have 0 equals 2x minus 3. Oh wait, crap. There's not an x there. Apologize. Is that where I messed up? Okay, so yeah, that's not an x. So 2 minus 3x squared. Move this over. Okay, I get negative 2 equals negative 3x squared divided by negative 3. So I get 2/3 equals x squared. X equals the square root, so plus or minus the square root of 2 over 3. That's a plus or minus. My board doesn't like me. So I have a whole bunch of critical points here, right? And that's from my first derivative. So I have a place in which that my derivative is not equal to, it doesn't work in there, right? Okay, so it's outside of my domain of my derivative. But do I have any others inside this right here? That part by itself. Is that also the same domain? It's got to be between between -1 and 1, right? Okay, so that's good. So that still works for all of this. So there's that. So I get that for my, let's see, I'm going to use this. I'm going to use this here after I combined everything together. And that's my first derivative. I just took this one right here and I cleaned it up so we could start doing the factoring. But I'm going to use that as the first derivative. So I get 0. And So, this one right here, we could actually figure these out by just plugging in numbers in between. So, let's go ahead and take these numbers here over to my calculator. Handy dandy calculator, which I know you guys all bring with class with you. It's like I gave you a super nice fancy calculator that you never want to use. Where's your backpack? That endless void of starry Naya cat?
Socks in here.
Okay.
I love Naya cat.
Okay, I wonder why. Why did I just automatically guess that? You ready? So, control, divide, set it up, and it was 2x quantity 1 minus x squared close raised to the 1 over 2 all minus x cubed parentheses 1 minus x squared close raised to 1 over 2 oh where does it not like minus, that's right. There you go. So this is a graph of my derivative. And if I zoom this in, 4, and let's go from negative 1, messed up on me, 4, 1, negative 1, 1, there you go. There we go. Now, guess what this number is right in between the negative 1 right here, where it's crossing the x-axis. Guess what that is?
Right. Square root.
2 over 3, right?
Yeah.
That's my negative square root of 2 over 3. Okay, so I found that point. So I know that one is going to be my point right there. Right here, it crosses the x-axis right there. What's that point? 0, right? And over here, it crosses that point right there. Guess what that one is? The positive rad 2 over 3, right? Okay. So now that's from my first derivative right there. So, what do we know happens in between, remember this is graph of the derivative, right here on the left of my negative rad 2 over 3, all that slope is right here on this side, the left side of it. All this over here is positive, isn't it? Is it above my x-axis? If it's above the x-axis, and this is the graph of my derivative, that's positive. And then over here, it's negative. So what happens when my graph goes from a positive to a negative? What does that imply? goes from a positive to a negative. That's a positive, right? So therefore that is a maximum. And what do we know about that maximum right there? What do I know about that concavity? It's concave down. That's why I'm throwing up these gang signs here. So it's concave down. Alright, so now if I'm changing right here at 0, I'm going from a negative to a positive. Going from a negative to a positive, that right there is that's a minimum, right? Minimum. And what's that concavity? There we go. And over here, this point right here is going to do the same thing. And it's going from positive to negative. So going from positive to negative, that means that's going to be a maximum. That's a maximum. And there is concave down. Okay. So what was the questions on this one? I got concavity, points of inflection. Now, points of inflection. So now, when we took the derivative, we found where the derivative is equal to 0, right? Where the derivative is equal to 0, that means it's changing, right? Okay? So, if we were to do that again, to find my inflection points, that's where my second derivative is equal to 0. So looking at this graph, where do you think that the second derivative is going to be equal to 0? You can estimate it. They're in 0.1 increments. What's the slope right here? The second derivative gives me the slope of the slope. So that means where the slope becomes 0, that would be right here. So that's 1, 2, 3, 4, 5, 6, 0.6. About 0.6 should be where my second derivative is equal to 0. What about this side? Same thing. Got about negative 0.6, right? That's where my second derivative is equal to 0. So we could do that. And we could use this information here to actually give me that. Because it's changing from here. Right here it's increasing at it, right? At a decrease. So right here, increasing. So it's going down faster up until this point. At this point is where it changes concavity. Right here, that is going to be, it's still negative, but it's now becoming less negative. These calculators are super smart. So let's try and find where that would be a minimum in this case. There it is right there. Now let's go to see what the maximum would be. Ah, dang it. Menu 6. Maximum. Ah! There you go. There's our maximum right there. So that means that those are my two places where it's actually going to be my inflection points where it changes concavity. And all this right here was question 57? Yeah. Alright, so let's go ahead and take a look at, let's finish up the notes here. So, finishing up the notes for those people following along at home. Obtaining information about the graph of f from the graph of the f prime and f double prime. So looking at the graph, this is the graph of the derivative. So the things I want to look at are the place in which that it's equal to 0 on both of them. Equal to 0 would be right here and right here. So if I were to try and make the graph, because these are f prime and f double prime, let's just do a graph of f of x and see what it would be. So what's happening right here from negative infinity up to 0? What type of slope is that? It's a positive slope, right? So it's increasing up to a certain point. Right here, when it gets to 0, then it starts decreasing. So if it goes from increasing to decreasing, what does that tell me? That's is it a maximum, right? That's a maximum, so I know that my graph is going to have a maximum here, and it's going to keep doing that. And so right here, that's where it's equal to 0. This is the double prime. So this is the graph that actually changes concavity. So right here, since it's concavity, it goes up to 0, so that means it's going to change right there. But it goes from negative to negative, so it's touching at 0. So that means that over here, this is going to be concave up. Oh, not up, sorry, down. Okay, concave, and then right here, it's going down. So that means going down right here, and where this is equal to 0, I have a 0 slope. That means right here, it is going to change. That's going to be my inflection point, where it's actually going to start going this way. And right here, at this, that's going to be my minimum. At 4/3. My graph is not very good, is it? It looks like it's at 1. So it's going from negative to positive, so that means that's going to be a minimum there. So right here, given this, it is from this point, this changes right here from a concave down over here to concave up. This stuff is not the easiest trying to match what these things are, because you guys have been so trained that everything has to do with your original function. Because when you're looking at graphs that are not of the function, that's probably like the biggest jump I, even as a math student, I ever had to do. I had the hardest time with actually trying to figure this stuff out. So if it's confusing, okay, I'll work with you as much as we can to try and help you with this, because I know it's not that easy. Next thing. Right here, determine, this is step by step what you're going to do for each one of these problems. Critical points of the numbers f. So what does that mean? F prime. Find f prime of x, right? Find the derivative and set that equal to 0. Increasing, decreasing. These things right here, what can I use for this? My number line. What values at x does have a local minimum? Okay, that's changing from, for it to be a minimum, it's going from negative to positive, right? What values does it have a maximum? That is, this is negative. Maximum would be from a positive to a negative. Where is it concave up? Okay, that's where we get those values for. Concave down, less inflection. So this should be your cheat sheet for all these problems here. Should be. And since we did 57 already on the calculator, I'm going to skip the last problem over here. So we did that in the calculator, which is basically the same thing we did doing 57. So right here it is. So this is what this means. Second derivative test to find the local extrema. So if the second derivative is greater than 0, it's going to be concave up right here at the critical point when the first derivative is equal to 0. So I can plug this in to see what I get. Same thing goes for here. Second derivative is less than 0. That's when my f prime is equal to 0, so that's my critical point there. So I'm plugging in the critical point into my second derivative, and it's going to tell me the concavity of there. Is that the best way to say it? And here's the rules for what we get from there. When I plug it in, if it is less than 0, maximum, greater than 0, minimum. So we're going to like, share, and subscribe. Hit that notification button, right? Support my channel. Alright, so I'm going to stop here.